Hello everyone, welcome to today's class. This is a continuation from the video understanding propane refrigeration loop. I told you all I'm going to model the system and teach you how it is done. If you have not subscribed to the channel, it's free subscription for the first 1,000 persons. If you like the videos, I'll also say you click on the like button, click on notification, so once we have new videos, you'll be one of the first subscribers to have a glimpse of it. It's free subscription for the first 1,000 persons. By the time we hit 1,000 persons, the promo will be over. So let's go straight to the point. Okay, today we're going to model the propane refrigeration loop. So the idea is to compress propane at 50 degrees centigrade and a pressure of 389 kPa and a molar flow of 100, and definitely the composition, it's pure propane. Okay, here we go. So we have a converged feed stream. So we'll want to compress propane to a particular pressure. This will make the process go a little bit faster. There are different means of heating this experiment, but I'm going to use the fastest and the easiest. So at any time you can do the modeling yourself. Okay, that's what we do. We use the best and the simplest form to get you enlightened on how to do the job. So propane is being compressed. Okay, to a pressure of 200 kPa. So we go to worksheet. It's being compressed to what? 2000 kPa. Okay, so at this point we want it in a vapor form. Okay, so we have a converged in feed and outer product of the compressor. So when it is being compressed, we want to cool it off to a required temperature too. So we'll be using a cooler. And to a required temperature. And this time around, we'd like to change the phase. Okay, we'd like to change the phase of propane at this point. Okay, so we'll be changing the phase from a vapor phase to a liquid phase. Okay, we go over to worksheet and we want propane to exist at 25 degrees. Okay, and we want to change in the liquid phase, in the vapor phase. So we want it in a liquid phase. And here we go. So we need an energy stream for the 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 cooler. So we give it a name as cool Q. You can decide to use whatever name you want to use. You can use CQ, whatever, but just make sure you have an energy stream labeled. All right, here we go. So we have our cooler converged, and at this point we like to will I say drop the pressure of propane using a valve. The reason for the drop in pressure of propane at this point is to have a very cold propane. And if you have a very cold propane, it's very easy for you to cool off any liquid at all you want to cool off. All right, so we use a control valve at this point, not a control valve. We use an expansion valve. Okay, it's very important you know that an expansion valve is the valve that can do everything you want. So we want a pressure drop of propane at this point. So we go over to the worksheet, and we want the drop of propane in pressure of 200 kPa. All right, and now we have our valve converged. All right, okay, so at this point propane is really very cold here. Like I told you, we want propane to be very cold. So at this point we have propane at minus 13 degrees centigrade. Okay, and I told you at the last video the real reason for the propane loop, refrigeration loop, is to retrieve heat from an external source. So now we have propane at minus 19 degrees. The job is done, but we need to recycle this process, and this process means this propane, after it does the job of retrieving heat from an external source, it has to go back to the compressor. Okay, so we can save some extra money, and we can save some extra time to rest. Okay, so we don't monitor the system at all times because it's going to be a continuous process. So what do? We add our heater. Okay, at this point we have propane going into the system to be heated. Okay, so when it's heated, it goes back to the whole system once again. Okay, and you need an energy stream here, and that's that. Okay, so we send the same amount of we send the heated propane back to the system. Okay, so this is how it goes. I'm trying to make it look a little bit cool. All right, that will just take a little bit of Flowsheet modification. Okay, so this is it. This is the basic idea of the basic method of modeling the propane refrigeration loop. So propane comes into a compressor, Okay, and out of the compressor at 2000 degree 2000 kPa into a cooler. Okay, and out of the cooler in a liquid phase, all right, at 25 degrees. Okay, okay, you have to cool it off, and it has to be in a liquid phase, and down to a valve. All right, just to drop its pressure. All right, and when you drop its pressure, propane is now very cold and exists in both vapor phase and liquid phase. All right, and this is when it has the ability to cool off any process. All right, okay, so when it is very cold, it cools off every process. I'm taking every step easy, so it becomes easy for you. And after it does the job of the cooling at this point, it is sent to a heater. And the heater hits the same process back to where it all started. Okay, our temperature still remains 50, just as it all started. Okay, okay, so it would be nice and proper if I also teach you how to add a heat exchanger at this point. So you know what the propane does actually. Okay, so I'm going to add 3 more streams. Okay, I'm going to use stream 6 to represent another stream of propane. Okay, and this stream of propane is at 50 degrees and a pressure of 300 kPa and a flow of 100. Okay, and its composition, pure propane. And that stream is converged. All right, so all I have to do again is make sure propane goes into a heat exchanger, and cools off this. Okay, okay, and then goes back to the heater. All right, so I'm going to send the very cold propane in to the tube side. Reason because it is more efficient to send the cooler fluid through the tube and the hotter one through the shell. That's one of the basic and most efficient way to get this done. Okay, so remember, I want to cool off stream 6. Okay, and I want it to be out at stream 7. Okay, and now I need to add a pressure drop. Okay, so go over to parameters. Remember, it's always best to have the pressure drop of the lower part of any system. If there's a pressure drop, it should be the lowest of it should be at the tube side, and the one with most pressure drop should be at the shell side. Okay, now the system is on the specified. Okay, so now that is on the specified, we want, now it's my decision to notify what phase I want the output to be, the product that ought to be cool. Do I want it in a liquid phase or do I want it in a vapor phase? All right, I want it in a liquid phase, and now my system is converged. All right, and here I have a temperature cross. I can make it normal, but I want it to be this way, and I'm going to teach you that on the next video. So if you like this video, I'd like you to make a subscription and keep a notification. I'll teach you how to do this in the next video. All right, and now that it's being converged, we send stream 5 back to the heat exchanger, and propane is as good as a very good coolant right now, because it has done its job of retrieving heat from the system and back to a heat exchanger. All I have to do right now is to modify the flow sheet. All right, so it looks a little bit less complicated. All right, if you follow all the guidelines, it's going to give you a very good result. All right, I started with the practicals so you don't get confused. I think at the end of this video I may have to give you a rundown in a few sentences of what this is all about, but for now I would like to modify the flow sheet. Right, the modeling is done. It's just the modification of the flow sheet. So I want you to have a very good view of what it's all about. Okay. Okay. Here we go. So propane loop, I added the heat exchanger to the propane loop to further clarify the video of understanding how the propane refrigeration loop operates. So I did a very good modeling of the system. Now this is propane loop in action. Okay, this is propane loop when it is active, working. All right, so this is the heat exchanger. It goes in here and retrieves the heat. Remember, we started at what, 50 degrees centigrade, pressure of 300 kPa and the flow of 100. And let's see how much heat was retrieved. Wow, you see, it did a very good job. It retrieved the heat to the extent that propane, it's now minus 9 degrees centigrade, all from 50 degrees centigrade, and the pressure of 250 degrees, 250 kPa. All right, our flow still remains the same. Wow, so that's the job, to retrieve heat. All right, it has done the heat reduction from this stream 6 and out on stream 7 at minus 9 degrees. And now that it's done the job, let's see. Wow, it is at 95 degrees centigrade. Okay, so it gained a whole lot of energy trying to retrieve heat from stream 6, and we send it to a heater. The heater hits it all back to all where it started, and where we have it at 50 degrees, 389 and 100 degrees. All right, if you like the video, I'd like you to subscribe, and at the same time click on the notification button, like the video, and see you in the next class, where I'm going to tell you about the reason why we have a temperature cross. All right, this is one of the situations most people have. All right, most times people use it this way, most times they don't. But when you have a temperature cross, you have a temperature problem. All right, so you can't solve one temperature problem and have another temperature problem, except you need the temperature to be working elsewhere. So that's why I told you, sometimes people work with it this way, sometimes they don't. So whenever you have a temperature cross, there's still a way out. All right, see you in the next video. Have a good day.